Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth.
Hello everyone and welcome back to Physics with Beth and Beth. I'm Beth and today we are continuing our discussion of AP Physics 1 Unit 5, which is on torque and rotational dynamics. And so today we're just going to be doing a little bit of practice with unit conversions on the units that we're going to be working with in rotational motion. So these are the big three units that you're going to be handling. And we'll talk about them for just a second. So first you have radians. Now you do remember that 2 pi radians is the same as 360 degrees, which is the same as 1 revolution. So these are three different ways we can talk about how much turnageness there is in a single circle. We can take a circle and we can break it up into 360 pieces, pretend there are 360 pieces here. And that ends up being a really easy way for our human brains to wrap around how much of a turn this is. 360 degrees is 1 full revolution, like that. 180 is half a turn, and so on and so forth. We also like to use radians because just like 360 degrees is easy for our person brains to wrap our brains around, radians, 2 pi, ends up being a really useful number that shows up a lot in the natural world. So whenever we measure the amount of turniness, that's an official scientific term, in a circle with 2 pi, a lot of the factors of 2 pi end up canceling out, and it makes our math so pretty and simple and easy. But this is easier for us to conceptualize and measure a lot of the time. Or we can just say 1 revolution is 1 full turn. So we're going to do a little bit of practice in converting between these three, but just remember that these three things are all equal to each other. So 2 pi, 360, and 1 are going to be the numbers we're going to be using a lot today. All right, let's just go through a few examples. Let's say I have, you're on a problem on the AP exam and you need to convert degrees to radians. So let's say I have, for example, 565 degrees and I need to convert that to radians. Well, anytime you do any type of unit conversion, it's just like what you guys are used to in dealing with linear units. You guys know how to convert feet to inches to miles to meters to centimeters and all of that. It's going to be exactly the same kind of process. I like to use train tracks like you might have learned in doing dimensional analysis if you've done that before, but I have 565 degrees over 1. I need to convert that to radians. So I'm going to multiply it by something. I need to have degrees in the denominator so that my degrees cancel out. I know that 565 degrees, okay, I have 360 of those in a circle, putting that on the bottom so that my degrees cancel out. And I'm trying to convert to radians, so I need radians up top. I know there are 2 pi radians in a circle. 2 pi radians is equal to 360 degrees. So this whole fraction is really just a fancy secret 1 that converts my units. This value on top is equal to the value on the bottom. So I'm not actually changing the value of my original measurement. I'm just changing how it looks by changing the units, right? So now if I have 565 times 2 pi divided by 360, I end up with 9.86 radians. Okay, so that's one example. Let's go through a couple more of these just for practice. So example number 2. Let's say I have 23 radians and I need to convert that to degrees. Because my calculator spit out this 23 radians number and I have no idea how many turns that is, so I'm going to convert this to degrees so it's something that I can actually see and measure and think about. So first I have 23 radians. I'm going to do my little train track method and put that over 1 to turn this into a fraction because I like fractions. So if I'm doing my little train tracks, I have 23 radians over 1. I need to multiply this by something that's equal to 1 so that I don't change my units at all. But I want radians in the bottom, so I have 2 pi radians here. Now I have radians divided by radians. Those units cancel out. I no longer have units of radians. That's good. And I need to multiply it by something to convert me to degrees. Well, 2 pi radians is the same as 360 degrees. So if I put that up top, I'll have radians divided by radians and multiplied by degrees. I'm left with units of degrees. Then in the end, this is equal to 1,318 degrees. Okay, now that's a number I can kind of think about. That's multiple turns around in a circle. That's something I can visualize. Now, one quick comment, because this is a problem that both Miss Beth and I have seen students make on many an occasion. Whenever you're dividing by this 2 pi, and you're putting this in your calculator, if you click the divide key, and then you click 2, and then you click pi, you're going to get the wrong answer. Because if you do that, you're going to end up dividing by 2 and multiplying by pi. So make sure if you divide by 2 pi in your calculator, click divide, open parentheses. I need to gesture with my hands. Open parentheses, 2 pi, close parentheses, enter. So that you don't divide by 2, then multiply by pi, but actually divide by 2 pi. Or alternately, you can hit divide by 2, divide by pi. That will also work, but just keep an eye out for that because that's a mistake students make all the time. And it's not a mistake that they make because they don't understand what they're doing. It's a mistake that they make because calculators are silly and don't understand what we mean when we tell them things. So just be wary of that. It's an error that we see happen all the time, so make sure you don't make it, okay? All right, let's just do another quick example here. Let's say I had a situation in which I was dealing with an angular velocity. So I have a change in angles over time. So let's say I had something that was measured in RPM, or revolutions per minute. So I have something that is rotating at 32 RPM, or revolutions per minute. And actually I'm going to erase all of this up here so that I have room to do this. Okay, so I have 32 RPM, which is the same as revolutions per minute. We're trying to convert this to units of radians per second for the sake of all of our lovely physics equations. Anytime you're plugging in anything into one of our big equations, you need to make sure your velocity measurement, your angular velocity measurement, has units of radians per second. Just like you need to make sure your mass has units of kilograms before you plug it in, you need to make sure your angular velocity has units of radians per second. This is the SI, or Standard International Unit, that you want to be using. So, radians per second, that's your goal before you do any calculations, okay? So, 32 RPM, if I want to convert that to radians per second, well, we can just do our little train track method. Okay, so we have 32 revolutions per every 1 minute. Let's first worry about getting this revolutions out of the way, and then we'll worry about changing this minutes to seconds. So how many, I'm trying to get to radians. How many radians are there in 1 revolution? Well, I erased it, so now you can't see. But there are 2 pi radians in a circle, or 1 revolution in a circle. So I'm going to put 1 revolution in the denominator, and I'm going to put 2 pi radians in the numerator. My revolutions cancel out with my revolutions, and I'm left with units of radians in the numerator, so that's good. 2 pi radians is equal to 1 revolution, so I'm not changing anything by multiplying this value by like a secret fancy 1, as I often say to my students. Okay, now we need to convert from minutes to seconds. Well, how many seconds are in a minute? 60, okay? So now I just need to make sure that I put, if 60 seconds is equal to 1 minute, I need to multiply my original value by a fraction of these, but minutes I know I need to put in a place so that it cancels out this minute right here. So I'm going to put 1 minute in the numerator because I'm trying to cancel out the minutes that I have in my denominator. So now I have minutes divided by minutes, and that goes away. And then in the denominator, I'm going to put 60 seconds. And there we go. And so now if we want to convert from revolutions per minute to radians per second, we just multiply 32 by 2 pi and divide it by 60, and we end up with radians per second, which ends up giving us a value of 3.35 radians per second. And there you go. All right, so that is all that I have time for today. So we're gonna put a stop to this here, and we'll pick up more with this in our next video. Thank you all for sticking with me through all of that. Y'all are troopers and happy physicsing.